Hi there, I'm Larry Chu, Professor of Anesthesiology and Executive Director of Medicine X at the Stanford School of Medicine. Welcome to 3D printing and bioprinting in medicine. In this course, we will explore how 3D printing and bioprinting technologies can be applied to healthcare and solve problems that currently require complex and costly solutions, ultimately improving the quality of care for our patients. We will learn from experts from a broad and diverse array of backgrounds, including Evan Koister from 3D Systems, Dustin Headley from Kansas State University, Stephen Keating from MIT, Jonathan Butcher from Cornell, Michael Fenn from Florida Institute of Technology, and my colleague Vahid Sarposhian from Stanford Medicine. Each module will feature brief lectures and interviews with industry experts, as well as short quizzes and reflection questions to make your learning stick. First, we'll take a virtual field trip to the 3D Systems office in San Francisco, where our Medicine X Makers Advisory Panel member, Evan Koister, will show us a rich collection of 3D printed items, as well as some of the printers. Let's get started.
Hi, my name is Evan Koister. I'm an advanced applications engineer here at 3D Systems, and I'm here to give you a tour of our facility. During that tour, we'll be showing you a bunch of different items that we print here and some of the machines that we use to print these items. We try and help clients basically brainstorm making their products better through the benefits of 3D printing. These are some examples of the 3D printed prosthetic arms that we've designed here at 3D Systems. Some of the goals with designing these prosthetic arms was making them cheaper, easier, and nicer to wear. A lot of them are designed for kids. As they flex their wrist forwards, it closes the hand, giving them back a gripping motion. And you can then modify this particular design to fit an individual's needs. And so this one comes out of the printer as one piece. There's no assembly required, can't break. And so this not only reduces the cost of creating a prosthetic hand, but as the child grows, you can just scale the file up with them and keep printing them out different objects. One of the groups we have here at 3D Systems is a division called Medical Modeling. And this is a division that specializes in basically helping doctors with their procedures. They go through a variety of different areas and different medical devices and procedures. It's an example of a torn tendon. He went to the doctor, got a CAT scan of his arm or an MRI. We pulled out that data to create a printable file of it. And so we then sliced it off, colored the different parts for easy viewing, and then gave it back to the doctor. So this allowed the doctor to have a very up close and personal look at the specific injury without having to actually open them up. They do a lot of conjoined twins and other more complex surgeries that require a lot of advanced planning. This is a 3D print done for a surgical planning model of a facial operation. And so as you can see, there are cut lines made all around the patient's jaw that have been printed out in advance to show the moves that need to be done. This helps reduce the time on the operating table so that surgeons don't have to guess when they get in there, or they're not figuring things out as they go. Or you can see that this foot is not a completely healthy foot. This would help doctors plan on what they would want to do, or maybe create an arch support or some other device to help this patient walk. One of the things we make in our medical modeling division and on a lot of our 3D printers are drill guides for complex surgeries. So this is, I think, a knee replacement. So what will happen is they will go in and they'll screw this directly onto the patient, make the incisions, and so these incisions will help control both the depth and the accuracy of the cut. And so once it's been drilled on and they've made the incisions, the bone comes out in a perfectly controlled and designed way. And so once we've pulled the bones off, they replace the drill guide, screw in the actual parts we're replacing, say an artificial knee, and then continue on with the surgery. Some of the benefits of these things is they take what would be complex surgeries from, say, a 30-hour surgery down to a 10-hour surgery. This is an example of a drill guide that would be screwed to a patient's fibia. And so this is used for a jaw replacement. In advance, the surgeon will go in and map out all of these cuts. They'll go and make the incisions on the patient's fibia, break it apart, and they'll use that to rebuild a patient's lower jaw. And so this is an example of a lower jaw replacement created from the patient's own bone. And this not only reduces the overall time in the operating room, but because we're not using a cadaver or something else, there's no risk of rejection. One of the major industries that 3D printing is helping to revolutionize is the dental industry. And so a lot of different benefits come from 3D printing, both the accuracy of our highly accurate printers, and then the ability to make custom objects. And so they'll print out the lower mold, vacuum form a skin-safe plastic over top of it and cut it out, but because the mold needs to be custom to the patient, They print out each mold, and it's something like 180,000 custom devices every single day. And so they also make a lot of dental planning, and so they'll go in, take a cast or take a scan of a patient's mouth, then print out the parts, and so the dentist can now work on creating teeth or retainers while not directly inside the patient's mouth. And this is an example of a heart. So it's printed in a flexible material to simulate the same structures that it would be inside a normal human heart. The doctors will have these printed out, and because it's the same texture as a regular human heart, that they can go in and practice on this heart before surgery. So the more times a doctor can practice on a particular patient, the better the likely outcome. And you can go run training simulations on this particular patient. Here at 3D Systems, we have a variety of different printing technologies. This is our largest printer in this category of consumer printing. And so it basically extrudes a piece of plastic somewhat like a hot glue gun. And it'll do that in a particular cross-section over and over again, slowly building up the part until you get a part that looks something like this. These were great learning devices. Most schools now have these kind of printers. These are one of my favorites for prototyping. They're very cheap, quick, fast, easy to use printers. This is an example of one of our powder bed printers. And so it's laying layers of very fine powder down, and then it'll repeatedly print layers of binder over top on the cross section. This works a lot like printing a piece of paper in exactly the same spot over and over and over again, slowly building up layers of binder and ink. So this printer is capable of printing in full color, which is one of the nice little details about this, as well as because it is a powder bed printer, the support material is a powdered material as well, so it just dusts off the part when you're done, and then you finished with your part. As you can see, each time it rolls a very fine layer of powder across, and then the printer will then print a cross section of the part. This is an S Pro 60. It works by a laser will come and selectively melt a cross section of the nylon powder together. This is the print bed, so this is where the parts are created, and these are where the excess material is stored before being printed. The first thing that happens is these platforms will raise up a very small amount, 100 microns, and this platform will drop 100 microns, and then this roller will come by and scrape a very thin layer of nylon powder across this cross section, and then depositing in the excess powder in these overflow containers. Then the next step, the laser will turn on, melt a particular cross section of the part into the plastic, and then let it cool for a moment or two, and then the roller will come from this side and scrape a new layer of powder across it. And this process will then repeat over and over and over again, sometimes thousands of times, slowly building up a nylon plastic part. The parts come out in a block of powder, much like this. Once the part has been printed, you come over here, break apart the powder, so it comes out of this powder fully finished like this. You come in, dust off the excess material on this part. Once you're finished cleaning this part, you're good to go. And so as you can see, this was not assembled. This comes out ready to go, and then the fingers and thumb all just start working right away. Another fantastic way of creating assemblies, this would normally require at least 16 or 17 different pieces to create this hand. We've brought it down to one object that comes out of the printer in I think as little as 5 hours. This is actually the first kind of printer ever invented by our founder Chuck Hall back in the early 80s. You've got a large vat of UV curable resin on the inside, and a laser will come by and draw the cross section of the part on the surface of the resin, and then the build plate will lower down, come back up again, and the laser will come by, draw a new cross section of a part in that exact same location, and slowly build up the part over the course of thousands and thousands of layers. So this is the most accurate type of machine because it's basically based on the accuracy of the laser. So if you've got a very accurate laser, you can draw very accurate parts, as well as some other little factors in material science that allow us to create highly accurate parts. This is a UV laser that is curing a UV curable plastic on the part. And so because this is a resin or a liquid-based support material, you can now draw very fine features. So these are used a lot of times for microfluidics. And so this will allow the resin to drain out through the holes after the parts have been printed. They also use these machines a lot in, say, the dental industry. A lot of the resins are skin-safe resin. And so they'll print thousands and thousands of these teeth a day on these machines. So thanks for coming with us on this tour of our 3D Systems San Francisco facility. I hope you've enjoyed and learned some things about 3D printing and some of the industries that we work in. My name is Evan Kuster, and thanks for joining us.